Welcome back. I am Dr. Nitin Naik from the Department of Structural Engineering, Sanjeevani College of Engineering, Kopargaon. Friends, in our second video, we have discussed about the terms related to earthquake and uh, various sources of earthquake, etc. So, we started our discussion with interior of the earth, as well as we discussed the definition of earthquake, various sources of earthquake, natural and man-made sources, and the theory of plate tectonics or plate tectonics. Then we discussed about formation of volcanic arc, formation of mountains on the interface of ocean and continent, and we have discussed about the term subduction, what is meant by subduction and how it takes place. Now we will discuss the hypothesis of gravity loading which may trigger the earthquake. So here these are the three figures A, B and C. So here this is continental crust and this is oceanic crust. The crust which is supporting the ocean and the crust which is supporting the land, and this is the interface of oceanic crust and the continental crust. Now in due course of time the sedimentation takes place along the interface of this oceanic crust and the continental crust. Along this interface the sedimentation takes place, and this process is a lengthy process, and this sedimentation it continues over year and it spreads, and thus the load acting on the continental crust and on the oceanic crust it increases, and because of this increase in load of this sedimentation the deformation of the oceanic crust takes place, and it starts moving under the continental crust, and thus the subduction takes place and which may lead to earthquake. So this is gravity loading hypothesis which may trigger the earthquake, or which can be explained as one of the causes of earthquake. So first one was the tectonic movement or the theory of plate tectonics, and the second one is gravity loading hypothesis. Now as discussed earlier, the entire earth surface is divided into continents or divided into different plates, and these plates are constantly moving. So let us talk about the Indian plate. The Indian plate is currently moving in northeast direction with a rate of 5 centimeters per year. With a rate of 5 centimeters per year, though it appears that the rate is very less, but in if you consider this process is continued over thousand of years, so you can imagine the displacement of the Indian plate. The Indian plate is currently moving northeast at 5 centimeters per year, while the Eurasian plate means you can call it as Tibetan plate. So Eurasian plate is moving in the north direction with a speed of 2 centimeters per year. So 2 centimeters per year towards north and 5 centimeters per year in northeast direction. So directions are different. This you must note it. Directions are different, and because of this movement of these two plates, it causes or it is causing Eurasian plate to deform and the Indian plate to compress at a rate of 4 millimeters per year. So because of this, because of the relative motion between these two plates, the Indian plate is subjected to compression at a rate of 4 millimeters per year, while the Eurasian plate is rigid. Its speed is less if you compare it with Indian plate. Okay, and it results in increase in height of Himalaya. So this motion or this movement resulting in increase in the height of Mount Everest at the rate of 2 centimeter per year. Now this figure, it shows the position before the collision of the ocean crust at the Indian plate's edge plunged under the Eurasian plate. So this is the position before the movement. So this is Indian plate which is moving towards the Eurasian plate. The Eurasian plate is stable one as compared to the Indian plate, and this is sedimentation which is there at the interface of ocean and the Eurasian plate. And before, at the interface, there was a ocean. Tethys Ocean was there, and because of this motion and compression of Indian plate, now that ocean is replaced by Himalaya. So at the place of Himalaya, this ocean was there. Tethys Ocean was there, and now Himalaya is there as a result of subduction of Indian plate below the Eurasian plate. So this is one more example of plate tectonics, or earthquake because of movement of the plate. As you might have noticed, there are frequent earthquakes occur at the boundary of India and Nepal and Tibet in the northern India. This is only because of the movement of the Indian plate. So you can see here in this figure, you can see the position of Indian plate 8 million years ago. India was an island. Slowly it is moving towards northeast, and this is the present position of the Indian plate, and still it is moving in the northeast direction with a speed of 5 centimeters per year. So this is one more example of plate tectonics. Now the second theory which can be discussed as one of the causes of earthquake is elastic rebound theory. Now, the elastic rebound theory is an explanation for how energy is spread during earthquakes. As rocks on opposite sides of a fault are subjected to force and shift, they accumulate energy and slowly deform until their internal strength is exceeded. So, here we will consider two rock masses, and this is fault which is there, and along this fault these are the two rock masses, and these masses are moving in opposite direction. These are the arrows showing the direction of movement of rocks. Okay, and the deformation is ductile, and we know when ductile material is subjected to deformation, it stores use energy. And this movement of these two rocks, it continues it continues and because of this movement, the rocks accumulate energy and slowly deform until their internal strength is exceeded. Once the internal strength is exceeded by the movement, by the deformation, then suddenly the strain energy which is stored in the rock mass of this rock will be released, and this release of energy is nothing but earthquake. So at that time a sudden movement occurs along the fault. So this is the fault releasing the accumulated energy, and the rocks snap back to their original undeformed shape. So after release of this energy or strain energy, the rocks gain their original shape. So again they are in their original shape after release of the energy, but they are displaced from their original position. So this is elastic rebound theory. The rocks rebound back to their original shape after a release of strain energy. So it leads to earthquake. So this sudden release of energy is called as an earthquake. So this phenomenon, elastic rebound theory, can be discussed again with the help of one more example. Let us consider two blocks connected to each other with the help of a ductile stick. And now the right hand side block is subjected to movement in downward direction while the left hand side block is moving in upward direction. Now because of this movement, the ductile stick is subjected to deformation, and the deformation will continue. The deformation will continue until the internal strength of this stick is exceeded, and once it is exceeded, the stick will break, huge strain energy will be released, and again it will become straight after release of the energy. The stick will become straight after release of energy, or the stick will rebound back to its original shape after release of energy. Okay, so in this way the elastic rebound theory can be discussed. Again we can consider one more example of a road which is constructed across the fault. So this is the fault in the rock. Okay, so if a road is built across the fault as shown in figure 1, so this is figure 1, the road is perpendicular to the fault trace at point E. So this is the fault or fault trace, and the center line of the road is perpendicular to this fault trace. Where the fault is locked, the fault is locked at E. Fault is locked at E. There is interlocking between the left hand side rock and the right hand side rock. Okay, the far field plate motion shown by large arrows cause the rocks in the region of the locked fault to undergo elastic deformation. Now this is the arrow which shows the movement of the plate. Here in top view it is in downward direction, and here it is in upward direction. It results in deformation of the rocks in the fault region. Deformation of the rocks. The deformation builds at the rate of a few centimeters per year over a time period of many years. This is important. This process will continue for many years. When the accumulated strain, now when there is deformation, we know there will be a strain, and this strain is stored in the form of strain energy. When the accumulated strain is great enough to overcome the strength of the rocks, an earthquake occurs. An earthquake occurs. So when this deformation it overcomes the strength of the rocks, then the mass of this rock it fails along this fault, and the strain energy which is there in the rock mass will be released, and this release of energy is nothing but earthquake. And immediately after release of the strain energy, again the rocks on both sides of the fault will regain, or rather will rebound back to their original shape, and thus this theory, and that's why this theory is called as a rebound theory. Okay, so I will continue with this sentence. The deformation builds at the rate of few centimeters per year over a time period of many years. When the accumulated strain is great enough to overcome the strength of the rocks, an earthquake occurs. It is because of the release of strain energy. During the earthquake, the portions of the rock around the fault that were locked and had not moved spring back or rebound back, relieving the displacement in few seconds that the plates moved over the entire interseismic period D1 and D2 as shown in figure 3. So original position is D1, the position after release of the energy is D2. The time period between 1 and 2, so this is 1 and this is 2. The time period between 1 and 2 could be months to hundreds of years, while the change from 2 to 3 will be in maybe in seconds, like an elastic band. Okay. So the strain energy is stored from 1 to 2. The period may be in months or hundreds of years, but the release of energy takes place in seconds. Like an elastic band, the more the rocks are strained, the more elastic energy is stored and the greater potential for an event, means for an earthquake. The stored energy is released during the rupture, partly as heat, partly in damaging the rocks, and partly in the form of elastic waves. So, this is about the rebound theory or elastic rebound theory. So, thus so far we have discussed about the theory of plate tectonics, which is nothing but a theory of movement of plates, oceanic plate and continental plate. We have discussed its effect, formation of mountains along the trench line or along the interface of ocean and continents. Second, we have discussed about gravity loading hypothesis, which results in subduction of the oceanic crust below the continental crust. We have discussed an example of plate tectonics, Indian plate and Eurasian plates. They are moving. Then this is elastic rebound theory, how the energy is released, how the rocks rebound back to their original shape. So this is all about the contents of this lecture.